All right, lesson 2.3, properties of functions. Okay, we're just going to continue on our talk about functions, something we've been talking a lot about the last few days. So our learning targets for today, we're going to determine if graphs are even or odd, okay, by looking at their graphs and by looking at their equations. We're going to start using the graphing calculator. Okay, so we'll look at actual graphs on paper, and then we'll use the graphing calculator to talk about where functions are increasing, decreasing, or constant. We will also use the graphing calculator to locate local maxima and minima and find the average rate of change for a function. So why don't you go ahead and just pause really quick if you need to and get those learning targets written down in your notes. Okay, let's start talking about symmetry. So if a graph is said to be symmetric with respect to the x-axis, this means that every point xy that is on the graph, then the point x negative y is also on the graph. So that means it would be symmetric with respect to the x-axis. So let's take a look at what that would look like. So we have this graph here that is symmetrical with respect to the x-axis. So basically, what that means is your x-axis is the reflection point, okay, kind of like maybe a little, like a mirror here, and the graph is reflected, okay, is symmetrical about that x-axis. Okay, so as you can see here is a point xy. Okay, and if this point is reflected across the x-axis, the x value is still the same here, but then you have the opposite y value, okay, because it's going over the x-axis. So any point on that graph should do the same thing. So the x values of these 2 points stay the same, but they have opposite y values. If a graph is symmetric with respect to the y-axis, that means for every point xy on the graph, the point negative xy is also on the graph. So what that looks like is part of the graph, okay, you can see that it's symmetrical, and then the point of reflection is that y-axis. Okay. So if you look at these 2 points here that are on the graph, they have the same y value. Okay, they're still along this same line for the same y value, but their x values are going to be opposite of each other since it reflects over that y-axis to the other side. Okay, same with these 2 points here. They are right next to each other horizontally, so they have the same y value, but their x value is opposite, okay, since they're on opposite sides of the y-axis. So that is symmetry with respect to the y-axis. Okay. So again, a big thing that you're going to want to remember here is that this is negative xy if it's symmetrical with the y-axis, and this is x negative y if it's symmetrical with respect to the x-axis. Last little bit of symmetry that we'll talk about is if a graph is symmetric with respect to the origin. Okay? For every point xy on the graph, the point negative x negative y is also on the graph. So here's a graph that would be an example of reflecting across the origin, okay? Because they're going to have both of the points are going to be opposite. Basically what is happening is this point here first gets reflected over the y, so that's why we have negative x. It also gets reflected over the x, which gives us the negative y. Okay, so again, this point here, if you were to get from point A to point B, we would first have to reflect across the y-axis, giving us a negative x value, and then across the x-axis, giving us that negative y value. Okay, so if it's symmetrical with respect to the origin, if we have a point on the graph, its opposite point also has to be on the graph, complete opposite. So what we use this symmetry for is determining if a function is even or odd. Okay. A function is even if for every number x in the domain, the number negative x is also in its domain. Okay. Also, and the big thing you want to see here and be concerned about is that if you plug in negative x as your input, you should get the exact same function as your output. Okay, because remember, that means, okay, if you have a negative x and the same y, so we're saying our input is negative x, and our output would just be the same thing as the original output, y. Okay, that means that we have symmetry across the y-axis. Okay, so that's what it means to be an even function, is that it's symmetrical about the y-axis. And if we have an input of negative x, we're going to get the exact same thing as the output. The y stays the same. The output stays the same, x is negative. Okay. So what I'm going to do here is I'm going to input negative x into my function. Okay, so wherever there is an x, I'm now plugging in negative x. Okay, so that I get f of negative x. So negative x squared is a positive x squared, but I still have that negative on the outside. Okay. So when I plug in negative x, I get the exact same thing that I started with. So f of x is equal to negative x squared plus 2, and f of negative x is also equal to negative x squared plus 2. So that means that my function is even. It is symmetrical about the y-axis. A function is odd if for every number x in its domain, the number negative x is also in its domain, and when I plug in negative x, so f of negative x, I will get the opposite of what my original function was. Okay, so my input is negative x, and my output is going to be opposite of the function I started with. Okay, so this is negative x, negative y. So that looks familiar. That piece of symmetry, okay, is symmetrical with respect to the origin. Okay, so when we said if we have the original function, we plug in negative x to it and get negative y out, so the opposite of our original input, then we know that it is symmetrical about the origin, and that is considered an odd function. So here I'm going to plug in negative x again, and I get negative 2 times negative x cubed over 3. Now, one thing I want to make note of is the original function. Since I have negative 2 divided by 3, I have a negative divided by a positive, which can also be written as the whole fraction being negative 2x cubed over 3. Okay, so if we consider this whole fraction being negative, that means if it is odd, if it is an odd function, then when I plug in negative x, I should get a positive fraction. So I plugged in negative x, so now I have negative 2 times negative x cubed. Well, negative x cubed is negative x times negative x times negative x, which is still negative x cubed, okay, over 3. Negative 2 times negative x cubed, a negative times a negative, means we're going to get a positive 2x cubed over 3. Okay, so since my original function was negative, okay, and now my new function, when I plugged in negative x, is positive, that means they're opposite of each other, which makes this an odd function. let's do a few more examples. Okay. Before we do that, I suppose, let's look at the graphs of a few functions. So we want to state whether each function is even, odd, or neither, then state any symmetry. So as we can see for this one is going to have symmetry across the y-axis. So I have a point over here, and I have its opposite point also over here. Okay, and that it happens along the whole function. So all of these points are reflected across the y-axis. So this is symmetry about the y-axis, which makes it an even function. My next graph, so you can see on this one, all my points are being reflected. So I have this point here, its corresponding point is being reflected across the x-axis, okay, across this whole function. So it's symmetrical across the x-axis. Okay. Since it's symmetrical across the x-axis, there isn't, our only symmetry had was even and odd, or the only even and odd symmetry we had was either about the y-axis or about the origin. So this is symmetrical about the x-axis. Okay. But it is not even or odd. Okay, because the only symmetry for even and odd functions is either across the y-axis or across the origin. Okay. This next one, we can see that the points, so we don't, if we have a point here, I don't have anything that reflects across the x-axis only, and there's no points that reflect across the y-axis only. But if I were to put those together, okay, this point, if I were to reflect it across the x-axis and then the y-axis, I would get symmetry about the origin. Okay, so this is symmetrical about the origin, which makes it an odd function. Last one. Okay. Take a look at this. If I pick a point, I don't have any reflection across the y-axis. I don't have any reflection across the x-axis. If I were to try and do both, across the x-axis and then across the y-axis, I don't have any of that either. Okay, so this has no symmetry. Which means it is not even and it is not odd. So it's neither even nor odd. Okay, so that's finding even and odd functions just looking at their graphs. Okay, either looking for symmetry about the y-axis or symmetry about the x-axis. Okay, now the reason why we don't have any even or odd function definition for symmetrical about the x-axis is because this, if it's symmetrical about the x-axis, it can't be a function. Okay, so you'll notice that this graph here is not a function because it does not pass the vertical line test. So we can't have an even or odd function if it's not even a function to begin with. Okay, so that's why we either only have symmetry about the y-axis as our even and symmetry about the origin as our odd. All right, so we found even and odd functions looking at the graphs. So let's continue and do even and odd functions just looking at the equation. Okay. So again, for both even or odd, we always start by plugging in negative x. Okay. If it comes out exactly the same, then it's even. If it comes out exactly opposite, then it's odd. If it's not the same and it's not opposite, then it's neither. So let's start with number 1. I'm going to plug in negative x for all of my x values. Okay. Simplify that. Negative x to the 4th, so negative x times negative x times negative x times negative x is a positive x to the 4th, but I still have that negative out front. Okay. Negative x squared is negative x times negative x, so a positive x squared minus 4. Can't simplify it any farther, and you notice that the function that I started with is exactly the same as the function I ended with when I plugged in negative x. So that makes it an even function. Okay. Symmetry about the y-axis. Number 2, again, plugging in negative x to my function. So again, remember that this negative divided by a positive can be written as the entire function being negative. Okay, so let's write this over here. So this can be written as negative 2x over the absolute value of x. Okay, so the whole function is considered negative. And I'm going to plug in negative x here. Negative 2 times negative x is a positive 2x over the absolute value of negative x, which is the same as the absolute value of x. Those two things are equal to each other. So as you can see, I started out with a negative function here, negative 2x over the absolute value of x. When I plugged in negative x, I ended with a positive 2x over the absolute value of x, which makes this an odd function because they are opposite. Okay. Symmetry about the origin. So why don't you go ahead and pause the video and try and do number 3 and number 4 on your own. And then once you're ready, restart the video and see if you got the answers right. All right, so on number 3, when you plugged in negative x, you should have gotten 4x to the 5th minus 3x. Okay. So as you can see, both of these things are exactly opposite from each other. The negative 4x to the 5th, that started out negative and ended positive. The 3x started out positive and ended negative. So since everything in that function was opposite from what it started, that makes it an odd function. Okay, so symmetrical about the origin. In number 4, when you plug in negative x, you should have gotten x squared plus 3x plus 1. So the only thing that is opposite is the 3x. Everything else stayed the same. Okay, so it either needs to all be exactly the same or it all needs to be opposite. So since it's neither of those things, then it's neither even nor odd. Okay, let's move on to talking about decreasing, increasing, and constant intervals. Okay, so just looking at a graph, we want to determine the intervals of when this function is decreasing, increasing, or constant. And the thing you have to remember here is that we always read from left to right. Okay. So just like a book, just like anything else that you're going to read, you always read a graph from left to right. So even though these arrows, this arrow here looks like it's pointing up, Okay, we're reading the graph from the left to the right. So if I start at the very left, it starts higher and goes down as I go left to right. So this case, up to -4, my graph is going to be decreasing. Since there's that arrow there, that means it can start up as far and high as infinity. Okay, so it starts from negative infinity, okay, all the way up to -4. Okay, then I'm going to be decreasing. Moving on from left to right, this part right here, okay, here, let's do this color coding. So this was decreasing. From -4 to -2, reading from left to right, my graph doesn't go up or it doesn't go down. So that's considered constant, from -4 to -2. Okay. Continuing left to right, now starting at -2, my graph starts to go up. So it's increasing all the way up until it gets here where it starts decreasing again. So from -2 to 0 is when my graph is increasing. Okay, once it stops increasing, it starts decreasing again. Keeps going, still decreasing, still decreasing, still decreasing. Oh, until I get to 4. Then it's going to turn right back around. So from 0 to 4 is when my graph is decreasing. And then I go back up, increasing, increasing, takes a little turn, but it's still increasing and keeps going on until infinity. Okay. So the way that we would write this is we would say decreasing, okay, is going to be from -infinity to -4, and from 0 to 4. My increasing intervals are from -2 to 0 and from 5 to infinity. Lastly, my constant, where the graph is constant and doesn't change, only goes from -4 to -2. Okay, and those represent the intervals at which they are decreasing, increasing, or constant. Okay, so the big thing to remember always is that we're reading the graph from left to right. Okay, and then you tell me which x values, which interval of x values is it decreasing, increasing, or constant. So that puts us into the local maxima and the local minima. Okay, so a local maximum means that is just the point where the graph was increasing and then it starts to decrease right after. Okay, so on this side of the point, we were increasing, and then as soon as it got to that point at the top, it started decreasing on the other side. So there can only be a local max if one side is increasing and then it immediately starts decreasing on the other side. Okay, so the way we say this is that the local maximum is f of c and occurs at c. Okay, so this is whatever this number is, this is the local max. And that local max occurs at this point. It occurs here. It occurs at C. Okay? All that means is the point, okay, we want to say what y value it occurs at. Okay, that's our maximum. That's how high it is on the graph. And it occurs at the point C. So the other way then is going to be your local minima, okay, and that is just the exact opposite. So a minimum is when from starting on the left it was decreasing, the graph was decreasing, and then as soon as it gets to that point, it starts increasing immediately. Okay, so it has to be decreasing and then immediately starts increasing on the other side. Okay, so again, this is the local min. the y value, okay, the lowest point in that section, and it occurs here. Okay, so the minimum value is that y value, and it occurs at the point C. Okay, so there could be more than one of these on a graph. Okay, so that's why it's called local max or local min. It's not the complete, it is not the maximum of the whole function, it's just the maximum of that particular area, the local maximum. Okay, or the minimum, it's not the minimum of the whole function, but just the minimum in that area. Okay, the local minimum. So for example, if we have this function again that we were looking at, increasing, decreasing, or constant, okay, let's now locate any local max and local min. Okay. So again, the maximum is anywhere that it was increasing and then immediately starts decreasing. So you can see right here, we have a function that is increasing, and then as soon as it hits that top, okay, when it's done increasing, it just immediately starts decreasing again. So that point, that local max point, is going to be right here. So the max is at 5, okay, because that's the y value. That's how high it reaches. It reaches to 5, and it occurs at x equals 0. Okay, so the maximum value is 5, and it occurs when x is 0. So then local minimum, okay, so here we have the function decreasing, 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 and as soon as it hits its bottom, it immediately starts increasing again. Okay, so since I have decreasing and increasing, this point here is where that switch occurs. So that's our local minimum. So the minimum, the lowest point there is -2. That's how low it gets. And the local minimum occurs at x equals 4. Okay, so the local min is -2, occurring at x equals 4. Okay. So looking at the rest of the graph, okay, you want to, a lot of you would like to say, okay, from going from left to right, here I had this decreasing also. We had already determined that that was increasing. However, the part, once it hits its bottom, it doesn't start increasing again. It's just constant. So that would not be considered a local min, because in order to do that, it has to be decreasing and then immediately start increasing again. Okay, not constant. So we wouldn't have a minimum in that area. All right, so why don't you guys take a minute looking at this graph here, and I want you to figure out where the local max and the local min are. So that'll be points on the graph. Okay, where is it increasing, where is it decreasing, and where is it constant? So go ahead and pause the video and see if you can figure out those 5 things. All right, so here are those answers. So your local max should have been 2, 3. So this is the max, and this is the value at which it occurs. Okay, so the maximum is 3, and that occurs at x equals 2. So right here, there was no local minimum, okay, because even right here where we're decreasing, it goes to constant. It doesn't immediately start increasing, so we can't consider that a minimum. Okay, so the graph is increasing from 0 to 2. Okay, that's the interval. Decreasing from 2 to 7. And constant from 7 to 10. Okay, and those last 3 are those intervals. Okay, so in the learning targets, we talked about how we were going to look at graphs to determine increasing, decreasing, constant, max, and mins on a drawing of a graph that you're given and also on the calculator. Okay, so what I would like you to do is take out your graphing calculator to do this, and we're going to answer all of these questions about this function. Since I don't have the graph of the function yet, I need to graph it in my calculator so that I can figure out and answer these questions. Okay. So in your graphing calculator, the first thing you're going to do is graph the function that I've given you. Okay, so remember, this is f of x and y are interchangeable. So this is the same thing as y equals x cubed minus 3x squared plus 5. So that's how you're going to graph it in your graphing calculator. So go to y equals, okay, x cubed minus, minus 3x squared plus 5. Okay, and when we graph it, just go ahead and click zoom 6. That's the standard -10 to 10. Okay, if that doesn't work, you would have to fidget with our window, but when we hit zoom 6, that just gives us -10 to 10 on both the x and the y. So here we can see on this graph, we have some local max and we have some local min. Okay, it's also increasing in places, decreasing in places. Okay, so the first thing we're going to do is look for the local max point. Okay, so what we're going to do is you're going to hit second calc. Okay, we'll go ahead and write this in here. So second calc. And you can see on there that you can find value, 0, minimum, maximum. Okay, so we can do this to either find the max or the min. So you just do one at a time. So since we're looking for the max first, go ahead and choose that option 3, minimum or maximum. Okay, so I'm sorry, option 4, maximum. Okay, so we're going to choose max or min, depending on what we're looking for. So this time we're looking for the max. Okay, so it says left bound. So if you use your arrows from left to right, you can move that cursor back and forth. Since we're trying to find the maximum, I first want it says left bound. So my cursor needs to be to the left of the point I'm looking for. Okay, so here is my point I'm looking for. This would be to the right of it. This would be to the left of it. Okay, so you need to put cursor to the left of the point, okay, and hit enter. Okay, then it says right bound, question mark. So that means your cursor needs to be to the right of it. Okay, so that blinking cursor, just move your arrows. Okay, cursor to the right. Then hit enter. So what you've just done is you've told the calculator, I want you to find the maximum point between the two areas that I just told you. Okay, so you gave it a left boundary and you gave it a right boundary, and the calculator is going to find the highest point between those two boundaries. Okay, so hit enter. It says guess. Okay, so you can just get it pretty close to where we're trying to find. Hit enter again, and it will give you the actual point. Okay, so here we hit enter again, and it's given us the maximum. Okay, now it says -1.279 e to the -6. Okay, so that just means it's -0.000001. That is very close to 0. Okay, so we're going to say the local max is equal to 5. okay, because that's our y value. Our y value is 5, and it occurs at x equals 0. Okay? So the actual maximum point is 5, and it occurs at x equals 0. Okay? Let's do the same thing with the minimum. So you go back to, and we're going to go through all these steps 1 through 5 just over again. So step 1, do second calc. And this time we're looking for the minimum. So we're going to choose option 3, the minimum. Okay. So cursor to the left of the point we're trying to find. So now this is the point we're trying to find. So we'll go to the left of it. Okay. Hit enter. Now it says right bounds, so I need to put my cursor to the right of it and hit enter. Guess, so get it kind of close there, enter, and then it gives you that. So 1.999999999, we can go ahead and say that's pretty much 2. So my minimum is at 1. Okay, so my minimum is 1, and it occurs at x equals 2. Okay, so my minimum value is 1, and it occurs at x equals 2. Okay, so now that I know that maximum point and that minimum point, that's going to help me find where it's increasing, decreasing, or constant. Okay, so we can see on our graph where it's increasing, decreasing, and now since I have the max and the min, I can say those exact points. So we can see that if you're going from left to right, it starts by increasing from negative infinity, and it ends at the maximum point. Okay, so it's going to increase from negative infinity and ends where it hits that local max at the top. Okay, so my local max occurred at 0, so it's increasing from negative infinity to 0. Okay. As you keep going along the graph from that local maximum point, it starts decreasing. So that means it's decreasing from 0, okay, since that's where the maximum was occurring, all the way to where it hits that minimum. Okay, so that minimum occurred at 2, so it's decreasing from 0 to 2. Okay. Then it starts increasing again at 2, all the way to infinity. Okay. There was no constants on this graph. Okay. So you probably be a good idea to make sure you have those steps written down for your calculator, so that when we practice it in class and you have other problems that you need to do for that, you can take a look at that if you need a refresher. Okay, but that's finding local max min on the calculator. Okay. Last thing that we're going to talk about. Go ahead and clear this. Very last thing is we're going to talk about the average rate of change. Okay, so given a function y equals f of x, the average rate of change of f from a to b is defined as the change of y over the change in x. Okay. Now, this looks really weird, but I want you to really think about what this looks like. Okay. All the average rate of change is the slope of a line. Okay, so let's bring up this picture here. So I have this function, okay, and if I want to find the average rate of change between this point here and this point here, all I am doing is finding the slope of the secant line that would connect them. Okay, so let's see that again. So I want to find the average rate of change between these two blue points on my function. So all I'm going to do is draw a line between them and find the slope. Okay, that line has a fancy name, the secant line, but all I'm doing is just picking 2 points on my graph, drawing a line between them, and finding the slope. So basically what this is y2 minus y1 and x2 minus x1. Okay, so y2 minus y1 over x2 minus x1. That's all we're doing. Drawing a line between the 2 points, finding the slope of that line. Okay, which you all know how to do. Okay, so let's say that my points were at 5 and 16. Okay, so here's my point, 5, 3 and 16, 7. So I want to find the average rate of change between the two. So I'm just drawing the line that connects them and finding the slope. Okay. So the average rate of change in y over change in x, is going to be 7 minus 3 over 16 minus 5, which is 4 over 11. Okay, so if you're not given a graph, okay, the average rate of change, okay, again, we're trying to find the average rate of change of the function from -2 to 6. So what that is it's telling me that my x values are -2 and 6. What I don't know, so this is my x1, y1, and my x2, y2. What I don't know are my y values. So they give you the x values. Okay, so finding their average rate of change between -2 to 6, those are our x values. Okay. So then we need to find, if we're finding the average rate of change between them, we need to just find the slope of the line that goes between them. Remember, change in y over change in x, which is the y2 minus y1 over x2 minus x1. So if we're given our x values, we need to find the y values. So I'm going to plug in -2 for x to figure out what my y value is. I get 4 plus 4 plus 3 equals 11. Okay, so for -2, the y value that goes with it is 11. To find the y value that goes with 6, we're going to plug in 6. Okay, so 36 minus 12 is 24 plus 3, 27. So the y value that goes with 6 is 27. Okay. Plug that into our slope, and we get 27 minus 11 over 6 minus -2, which gives me 16 over 8, which is equal to 2. Okay, so my average rate of change from -2 to 6 would be 2. Okay, remember that is the slope of the secant line. Okay, slope of the secant line. So again, the secant line is just the line we drew between those 2 points and we found the slope of it. That is the average rate of change. Okay, so I know you guys all know how to find an equation once you're given the slope, so we're not going to go through that right now. Okay, but just keep in mind, average rate of change is just the slope of the line that we drew between those 2 points. So we got 2. Okay, so again, please make sure you bring your calculators to class with you, and we will be working with finding local max, local min, that sort of thing on your calculator, so you want to make sure you have those. Okay, and I will see you all next class.